The balanced injection of holes and electrodes into a thin-emissive quantum dot layer for efficient relative recombination is critical to the color purity, stability, and efficiency of the quantum dot-based light-emitting diodes. We proposed a partially oxidized aluminum cathode to enhance the electron injection and Exciton confinement for high-performance blue quantum dot light-emitting diodes.
The main advantage of this technique is that no additional electron transport layer is inverted in the device, which guarantees color purity and simplifies the fabrication processes.
Demonstrating the procedures will be done by Wen Sun, a grade 8 student in my lab.
To begin the procedure, cut a 12 cm by 12 cm piece of ITO-coated glass with a resistivity of about 10 ohms per square into 15 mm wide strips. Clean the ITO glass strips with a dust-free cloth and pure ethanol. Allow the ITO glass to air dry. Check the conductive side of the ITO glass for defects with a digital multimeter. Use standard adhesive tape to cover a 2 mm wide section lengthwise along the center of the ITO glass strip. Then, place the ITO glass in a shallow acid-resistant container, such as a petri dish. Pour zinc powder over the ITO glass to a thickness of about 0.5 millimeters. Pour 36